Lesson: Machine Translation and Language Generation. Machine translation and language generation are pivotal components of natural language processing, serving as the bridge between human communication and machine understanding. These technologies have revolutionized how we interact with digital systems, enabling seamless communication across languages and the automated generation of human-like text. This lesson will delve into the intricacies of these fields, offering actionable insights, practical tools, and step-by-step applications that enhance proficiency and address real-world challenges. Machine translation involves the use of software to translate text or speech from one language to another. It is a complex task that requires understanding both the syntax and semantics of languages. The most common approach to MT is neural machine translation, which utilizes deep learning techniques to model the translation process. An example of a practical tool for NMT is Google's TensorFlow, an open-source platform for machine learning that provides a robust framework for building and training NMT models. TensorFlow's seek-to-seek model is particularly effective for translation tasks, allowing for the conversion of sequences from one language to another. This model has been instrumental in improving the fluency and accuracy of translations, as evidenced by Google's translation services, which have seen significant improvements in recent years. To implement an NMT system using TensorFlow, professionals should first gather a large dataset of parallel texts, which are pairs of sentences in different languages that convey the same meaning. The next step involves pre-processing the data to ensure it is in a format suitable for training the model. This typically includes tokenization, where sentences are broken down into individual words or subwords, and conversion into numerical representations. Once the data is prepared, the seek-to-seek model can be trained, a process that involves feeding the model with input-output pairs and adjusting its parameters to minimize translation errors. After training, the model can be fine-tuned and evaluated using a separate validation set to ensure its effectiveness before deployment in real-world applications. Language generation, on the other hand, focuses on the creation of coherent and contextually relevant text by machines. OpenAI's generative pre-trained transformer models are among the most advanced tools in this domain. These models, particularly GPT-3, have demonstrated remarkable capabilities in generating human-like text, making them invaluable for applications such as chatbots, content creation, and automated summarization. GPT-3, with its 175 billion parameters, has set a new standard in language generation, allowing for the creation of text that is not only grammatically correct, but also contextually nuanced. The practical application of GPT models involves fine-tuning them for specific tasks or industries. For instance, a company in the customer service sector might tailor a GPT model to generate responses that align with its brand voice and address common customer inquiries. The process begins with the collection of a relevant dataset, which is used to further train the model on specific terminology and contextual nuances unique to the business. Tools like OpenAI's API make it straightforward to integrate these models into existing systems, enabling businesses to automate content generation while maintaining a high degree of personalization and relevance. A significant challenge in both machine translation and language generation is addressing biases present in training data. Bias can lead to skewed translations or generated content that reflects prejudiced views. It is crucial for developers to actively identify and mitigate these biases to ensure fair and accurate outputs. This can be achieved through techniques such as data augmentation, where additional diverse data is incorporated to balance the training set, and bias detection algorithms, which identify biased patterns in model outputs. By continuously monitoring and refining these systems, developers can enhance the reliability and equity of machine-generated language. Real-world case studies illustrate the transformative impact of these technologies. For example, multinational corporations like Facebook and Microsoft have integrated advanced MT systems to facilitate communication across diverse user bases, enabling users to interact in their native languages without barriers. Similarly, media outlets have harnessed language generation tools to automate news reporting, allowing for the rapid dissemination of information while freeing up human journalists to focus on investigative work. These applications not only improve operational efficiency, but also expand the accessibility of information and services globally. Statistical evidence further underscores the efficacy of machine translation and language generation. According to a report by Markets and Markets, the global machine translation market is projected to grow from USD 550 million in 2019 to USD 1.5 billion by 2024, reflecting a compound annual growth rate of 19.0%. This growth is driven by the increasing demand for cost-effective and efficient translation solutions in various industries, including healthcare, automotive, and e-commerce. Similarly, the adoption of language generation tools is accelerating, with businesses recognizing their potential to enhance customer engagement and streamline content creation processes. To ensure success in implementing these technologies, professionals should adopt a holistic approach that encompasses not only technical expertise, but also ethical considerations and continuous learning. Staying abreast of advancements in algorithms and frameworks is crucial, as the field of NLP is rapidly evolving. Engaging with academic literature, attending industry conferences, and participating in online forums are effective strategies for maintaining a competitive edge. Moreover, collaboration with interdisciplinary teams can provide diverse perspectives and enrich the development process, leading to more robust and innovative solutions. In conclusion, machine translation and language generation are integral to the advancement of natural language processing. By leveraging powerful tools and frameworks like TensorFlow and GPT, professionals can develop sophisticated systems that transcend language barriers and automate complex linguistic tasks. However, the responsibility to address ethical challenges and ensure unbiased outputs remains paramount. Through continuous refinement and ethical vigilance, these technologies can be harnessed to create a more interconnected and equitable world.